to talk about foundations of business intelligence, databases, and information management. First of all, we're going to present a case about R. Donnelly tries to master its data. R. Donnelly needs to manage multiple databases and sources of data coming from acquired companies. In a situation in which the total amount of data was too large to be managed well in a single source. In an age of non-organic corporate growth where companies grows by acquiring other companies, business firms quickly become a collection of hundreds of databases, email systems, personal systems, accounting systems, and manufacturing systems, none of which can communicate with each other. This creates a demand for powerful enterprises-wide or firm-wide databases that can bring order to the chaos. The solution for this case is use an MDM to create an enterprise-wide set of data, preventing an unnecessary data duplication. An MDM is a tool which can be used to support master data management by removing duplicates, standardizing data, incorporating rules to eliminate incorrect data from entering the system in order to create an authoritative source. And now we're going to present a video in which we explain deeply what is master data management. After seeing the video, we know that the objective of MDM is providing processes for collecting, aggregating, matching, consolidating, quality assuming, persisting, and distributing such data through an organization to ensure consistency and control in the ongoing maintenance and application use of this information.
Well, now we are going to talk about file organization concepts. Here we can see a hierarchy of data that is used to store information in database, progressing from the database at the top layer of order of information down to the field, which stores information about an entity's attribute. So first, in the first stage, we got the database, which is a group of related files. Then we got a file, which is a group of records of a same type. Then we got a record, which is a group of related fields, and field, which is a group of characters as words or numbers, which describes an entity, person, place, thing on which we store information. And the attribute of these fields are each characteristic or quality describing an entity.
Now I'm going to talk about the main problems with the traditional file environment, which are program data dependence, lack of flexibility, pure security, lack of data, data redundancy, and data inconsistency. Now I'm going to give you some examples about this. Okay, data redundancy. We have as you can see in the record above, the name is repeated 3 times and the age is duplicated twice. A relational database can avoid this duplication.
Well, and now we will continue with the database approach to data management. A data management system, or DMS, is a software that permits an organization to centralize data, manage them efficiently, and provide access to the stored data by application programs. The DBMS acts as an interface between application programs and the physical data files. When application programs calls for a data item, such as presents it to the application program. Using traditional data files, the programmer will have to specify the size and format of each data element using in the program, and then tell the computer where they were located. We will explain some examples. Well, this graphic illustrated what is meant by providing different logical views of data. The orange rectangles represent two different views in an HR database. One for reviewing employee benefits, the other for accessing payroll records. The students can think of Win Cylinder as a physical view, which shows how the data are actually organized and stored on the physical media. The physical data do not change, but the DBMS can create many different logical views to suit different needs of users. Well-known DBMSs include MySQL, Postgresql, SQLite, Microsoft SQL, Server, Oracle, SAP, DBase, and FoxPro.
Well, the three basic operations used to develop useful sets of data are select, which creates subset of data of all records that meet the stated criteria; join, which combines tables to provide users with more information that available in individual tables; and project creates subset of columns in table, creating tables with only the information specified. Well, now we're going to see what is object-oriented DBMS or OODBMS. And OODBMS stores the data and procedures that act on those data as objects that can be automatically retrieved and shared. Object-oriented database management systems are becoming popular because they can be used to manage the various multimedia components or Java applets used in web applications, which typically integrate pieces of information from a variety of sources.
Well, and databases in the cloud. A cloud database is a database that typically runs on a cloud computing platform, such as Amazon, EC2, GoWeb, and Rackspace, and we can include also iCloud model. There are two common deployment models. The first is that users can run databases on the cloud independently using a virtual machine image, or they can purchase access to a database service maintained by a cloud database provider. Of the databases available on the cloud, so some are SQL as Windows based, and some use NoSQL data model. Well, we will continue with the capabilities of database management systems. First, we have a definition of capability. Well, it specifies a structure of database content used to create tables and define characteristics of fields. Second, data dictionary is an automated or manual file storing definition of data elements and their characteristics. Third, data manipulation language used to add, change, delete, retrieve data from a database, such as a structured query language, SQL of Microsoft. And finally, we got that many DBMS have report generation capabilities for creating polished reports.
Now we're going to talk about designing databases. The conceptual design is an abstract model from business perspective, but physical design, in simple words, is how database is arranged on direct access storage devices. The design process identifies the relationship among data elements, redundant database elements, most efficient way to group data elements to meet business requirements, needs of application programs, and finally normalization, which is the streaming complex grouping of data to minimize redundant data elements and avoid many-to-many relationships. Okay, now we're going to present a small video about designing databases. As we after see the video, uh, we know to create an efficient database, you must know what the relationships are among the various data elements, the types of data that will be stored, and how the organization will need to manage the data. Note the Note that the conceptual databases designing concern with how the data elements will be grouped, what data in what tables will make the most efficient organization.
We use databases to improve business performance and decision making. Business intelligence is a set of theories, methodologies, architectures, and technology that transform raw data into meaningful and useful information for business purposes. Business intelligence can handle large amounts of information to help identify and develop new opportunities. Making use of new opportunities and implementing an effective strategy can provide a competitive market advantage and long-term success. Now we got an example. For instance, Harris Entertainment, the second largest gambling company in its industry, continually analyzes data about its customers gathered when people play its slot machines or use Harris casinos and hotels. Harris marketing department uses this information to build a detailed gambling profile based on a particular customer's ongoing value to the company. This information guides management decisions about how to cultivate the most profitable customers, encourage those customers to spend more, and attract more customers with high revenue generating potential. Business intelligence has improved Harris' profits so much that it has become the centerpiece of the firm's business strategy. That's the importance of the database management, as we can see. The principal tools of business intelligence include software for database query and reporting, online analytical processing or OLAP, and data mining. The online analytical processing, these tools enable users to analyze multidimensional data interactively from multiple perspectives. This consists of three basic analytical operations, which is the consolidation or roll-up, drill down, and slicing and dicing. Consolidation involves the aggregation of data that can be accumulated and computed in one or more dimensions. For example, all sales offices are rolled up to the sales department or sales division to anticipate sales trend. Now I'm going to talk about data mining. People use data mining to discover driven information, find hiding patterns, relation in large databases, and inference rules to predict future behavior. For example, finding patterns in a customer data for one-to-one marketing campaigns, or to identify profitable customers. Types of information obtainable from data mining. For example, associations, occurrences linked to a single event, sequences, which are events linked over time, classification, which recognizes patterns that describe groups to which item belongs, and forecasting use a series of existing values to forecast what other values will be. That's why data mining is very important in the data management. The text mining extracts key elements from large unstructured data sets. Example, stored emails. And in web mining, discovery and analysis of useful patterns of information from www. For example, to understand customer behavior, evaluate effectiveness of a website, etc. Now I want to talk about establishing information policy. Well, we got the firm's rules, procedures, role for sharing, managing, and standardizing data. These are some steps. Well, the data administration is the function of managing and maintaining database management systems, as I talked about the DBMS software. And the data governance is a set of processes that ensures that important data assets are formally managed throughout the enterprise. Governance ensures that data can be trusted and that people can be made accountable for any adverse event that happens because of low data quality. Ensuring the data quality. Data are of high quality if they are fit for their intended uses in operation, precision making, and planning, as GM Durant says. Alternatively, the data are deemed of high quality if they correctly represent the real world construct which they refer to. And to finish, the data quality audit, which is a structured survey of the accuracy and level of completeness of the data in the information system. For example, survey samples from data files or surveys for perception of quality. And to end the presentation, that data cleansing or data cleaning or data scrubbing is the process of detecting and correcting or removing corrupt or inaccurate records from a record set, table, field, database, etc., etc. Used mainly in databases, the term refers to identifying incomplete, incorrect, inaccurate, irrelevant, etc. part of the data and then replace, modifying, or deleting this data. The software to detect and correct data that are, of course, incorrect, incomplete, improperly, or redundant enforces consistency among different sets of data from separate information systems. Thank you very much. That was our presentation.